Hello students, welcome to Tuteetute. In this session, we will learn about the gas turbine power plant. So in the name itself, we got the name as the gas turbine power plant. So generally, hydroelectric power plant or thermal power plant or steam power plant. So any other form, okay, so we will be using as directly power plant. But why this one we are using as a gas turbine power plant? So that means the name itself it suggests, okay, so the turbine name itself suggests it has huge role in the power generation. Okay, so the turbine itself, it is the core element in the entire power plant. Okay, so core element means it will be a main component for the entire power plant. Okay, so that's what it means. Okay, so now about this gas turbine power plant, you are seeing the image, right? Okay, so this is a gas turbine power plant, that's it. So this is the entire thing. So upon this one, okay, so there will be some more components for this one. Okay, so you may get one doubt. Okay, so we have thermal power plant, hydroelectric power plant. In hydroelectric power plant also we have so many kinds. Okay, like we have pumped storage plant, runoff river with pondage, runoff river without pondage. That means continuously flowing river or discontinuously flowing, like only in a year 1 or 2 months water availability will be there. After that water availability will not be there. See here, so why we need this gas power plant? So there might be certain reasons why we have developed this gas power plant or gas turbine power plant. So think about one basic example we have. We have rocket launching systems, right? We have rocket launching systems. So for example, just think, okay, so there in the rocket, we need to ignite that one. So you might have observed, okay, so if this is a rocket, okay, so bottom of this one, there will be ignition and burning will be happening. Because of that force, the rocket will be going upwards. So this is a basic example we know, okay, so you might have observed, so in the recent science and technology developments in India also. So why we have this technology, how we are achieving this technology? We are burning some fuel inside. Inside this rocket, we are burning some fuel and we are converting that fuel energy or chemical energy into a force. With that force, that rocket will be going upwards. The similar kind of technology we are using here. So what we need to do? We need to burn some fuel. So basically, it is called as the combustion, right? So the burning of fuel is called combustion. Okay, so the basic definition. Okay, so I am not going into deep, okay, at present only. So soon we will be learning about each and everything in detail. Okay, so what is the process of combustion? So how here compressors are working, how here the turbine, gas turbine is working. So what are the major achievements here we have made? So by connecting 2 or 3 components. So one by one we will be learning. Okay, so before that, okay, so we have this thermal power plant and we have nuclear power plant and we have hydroelectric power plant. Why we need this gas turbine power plant? So because there are certain advantages for us. What kind of advantages? So let's take a thermal power plant. Let's take a thermal power plant. Thermal power plant means, what is a thermal power plant? For any thermal power plant, the input is coal. The input is coal. Coal input is there. That coal we have to burn inside a boiler. So we have certain process, okay, so economizers are there. After that, air preheaters also there. So many components we have. After that, we are generating the steam. From the steam, we are using that steam into a steam turbine. There, steam energy is converted into mechanical energy, and that mechanical energy we are converting into electrical energy by using one generator. Okay, so this is like entire thing is, it's called powerhouse, where turbine and generator will be there. That is called powerhouse. Okay, in powerhouse, the chemical energy will be converted into electrical energy, not directly. Okay, so it is like a mechanical energy is there in between. Later in the machine we have magnetic energy. Okay, magnetic form of energy also. Okay, so leave it. Input is here is steam and output here is electrical energy. Okay, so that is there for the thermal power plant. So but what is this gas power plant? So do you think like from the gas power plant We are generating the steam. See, combustion is happening here. What we are doing with this combustion? So firing is there. Okay, we are firing certain fuel. Why we are firing this one? Because you will definitely get the heat energy, right? So are we using this heat energy to convert some water into steam? No, we are not using like that. Okay, so you might have observed with so the rocket example. Okay, so what we are doing there is no water. We are producing certain kind of energy. So mechanical energy we are producing. With that, it is lifting up at each and every stage. Any kind of rocket it is. Okay, so why to go for up to that technology? Okay, so we have very simple thing. So we have our cars, or we have bikes. So in car or bike, what kind of technology is there for the ignition? Okay, see, burning process is happening inside the engine. We have given certain fuel to that. That fuel will be burned inside and it is producing certain kind of mechanical energy. So that's why these vehicles are moving, right? So forget about whether that is a gas fuel, otherwise diesel, otherwise petrol or anything else. Okay, so no need to worry about this fuel. Some fuel we are burning inside and we are converting that chemical energy of that fuel into mechanical energy by using certain technology here. Similar to this gas turbine technology also there. So what we are doing here, we are using the fuel as the input and we are doing combustion inside, and from the output of this combustion we are converting into an electrical energy. Okay, so that's what the basic thing. Okay, so but why we need gas turbine again? Okay, see there are so many reasons. Operation we are understanding actually, so many reasons are there. So one of the major advantage we are getting using this gas turbine power plants is it's easy to generate the power within very short time. A thermal power plant, generally it will turn on. So from the cold reserve to the generator, as a generating plant, it will take 6 to 8 hours. So we might have learned already in the comparison of power plants. Okay, so 6 to 8 hours of time required. Okay, so first we need to build up the boiler. After that, so we need to start the generator. Okay, so then freely it has to run for certain time. Then only it can connect to the grid and generation will be started. So that's what the entire thing. Okay, so this will take at least 6 to 8 hours for a thermal power plant. Okay, so then for the hydroelectric power plant, so hydroelectric power plant means what is the input? Water is the input. So that means hydro energy is the input. So here also how much time? Okay, so it will be taking means so a maximum of 10 minutes. Okay, so max of 10 minutes. Maximum of 10 minutes it will take. Anyhow, okay, so there will be surge tank operation here. It will be acting as surge tank in the thermal power, in the hydroelectric power plant, will be acting as a temporary reservoir. So we have learned already these concepts. Okay, so in the hydroelectric power plant, okay, so hydroelectric power plant, our surge tank will be acted as a temporary reservoir. So anyhow, okay, there is that application is different. Okay, so now it will take a maximum of 10 minutes. So depends upon the generator and the turbines we are using there, and depends upon the capacity of surge tank. It may increase, it may decrease to 4 minutes. Okay, so a minimum of 4 minutes, a maximum of 10 minutes. Okay, so this is how we are doing. That means whenever load changes immediately, like electrical energy requirement or electrical energy demand, okay, so it's more. For example, in terms of megawatts, it is increasing. Minute to minute, it is increasing. So we have to increase the generation rate. Otherwise, we have to shut down one of the substation. One of the feeder we have to turn off. So like this we need to understand. Okay, see, from electrical point of view only we need to understand this. Okay, see, whenever more electrical output is required, more generation need to do. More generation have to do within a rapid of time. Okay, like very short time we have to increase the generation here. But this power plant will take 4 to 10 minutes. This power plant will take 6 to 8 hours. Even it is running as a hot reserve, that means it is ready to give also, it will take at least 1 to 1.5 hours. Previously it is 2 hours. Now at present we have thermal power plants which are giving at 1 hour of preparation time. Okay, so within 1 hour they can start generation. Understanding? So transmission will take very less time only. Okay, so forget about this transmission. Start of generation. Okay, so that's what we need to have. Okay, so this power plant will take this much of time. This power plant will take 4 to 10 minutes. Even the 10 minutes also, it is like getting delayed, right? 10 minutes. Whenever power generation increased, power demand increased, then generation has to increase after 10 minutes only. Understanding? So this is about the hydroelectric power plant. So but what about nuclear power plant? Nuclear power plant. So nuclear power plant is similar to thermal power plant, and here also input is the steam only. So here also it will take almost like a similar time only. So we cannot use directly here. And one more problem also there with hydroelectric power plant, like 10 minutes I will turn off the load. After that I will just generate from the hydroelectric power plant. See what is happening. You have stopped the water, okay, you have constructed the dam, okay, you have constructed the dam, you have stopped the water. After that, whenever load increases, you are using this water to generate the power, to generate the electrical power from the hydroelectric power plant. How many days you will do like this? That river, like for example, okay, in South India we are, okay, so we have certain rivers which does not flow for entire year. So we have Godavari river, we have Krishna river, Tungabhadra river, so many we have, okay, so even Maha river also we have. So these are all the rivers where continuity of water will not be available. So that means ample amount of water is not available. So what you have to do? You need to construct the dam. That's where, right, if water is continuously available, no need of that much of big dam. Just check about Sri Salam power plant, how it is. So it is like a very big dam we have constructed there. We have stopped cusecs of water there. After that we are using that water. Understanding? So that means first you need to stop the water. Whenever load increases, will you use this water immediately? Like today increased, okay, use the water. Tomorrow increased, use the water. Day after tomorrow also load changes will be happening. Use this water wherever dam is there, okay, that water. And hydroelectric power plants, you have to increase the generation, because from this one, these are the base load power plants. You may have know already, okay. So like this and this, like nuclear power plant and thermal power plant will be acted as a base load power plants, and generally hydroelectric power plant used as the peak load power plant. Whenever load increases, at that time only, so we have to use this power plant. Okay, now every day like this power is increasing, like load changes are happening. We cannot go for this hydroelectric power plant. Why? Means water will be completed. If you use for 4 or 5 days or 10 days, 15 days, 20 days, 30 days, 1 month, entire water will be completed there. Some water will be evaporated, some water will be using again. You may get to know about the idea, okay. So use that power plant as the pumped storage plant. That means bottom whatever water is there, you can put it again here. Understanding? So that means even though you are doing like this also, there will be evaporation of water, there will be loss of some water, and again we are using certain electrical energy to pull that water to backwards. So that means anyhow, if it may not complete within 1 month, it will take 1.5 months, that's it. So, but water will complete if you continuously use this hydroelectric power plant. So depends upon all these problems to tackle with the load changes. Whenever load suddenly changes, what you have to do? You need to have a power plant. You need to have a power plant which will start immediately. Okay, so which will start immediately. Okay, so immediately means what is immediately? So just like our rocket, okay, so whenever ignition starts, within like 1 or 2 minutes only, so this will start the rocket will be going upwards, or even very less time at present. Okay, so you can observe, so very short time. Okay, so the ignition starts and within seconds or within 1 minute only we are achieving that energy conversion. Understanding? So we have different kinds of engines, okay, so like cryogenic engines at present we have developed, okay, and we are using in so many rockets at present. Almost 90% of the rockets we are using this kind of engines only. So what is the advantage we are getting here? So continuous cooling system also present there, and continuous energy conversion is also happening. So that's how we have reduced the time of conversion. That means similar to that, in our turbine, if any fast conversion rate is there, then it's easy to tackle with the load changes. More electrical energy increase suddenly, what we have to do? We have to go to certain power plant, so where immediately we can generate the electricity, just like our car engines, okay. So whenever you turn on, ignition starts, inside there will be burning starts and mechanical energy will be starting. So for that mechanical or rotating part will convert our generators. That's it, that much easily we can generate, okay. So like within like a very short time we can start the generation. So that kind of power plant we need. So that's what our gas turbine power plant. You see, understanding, okay. So there is certain requirement for this kind of power plant, because for a smooth operation, okay, you may think like, okay, why this much smooth operation? So you can't be here for like 1 or 2 minutes, or maybe this power plant for example, okay. So like 5-10 minutes you can be without any electricity, right? Why you will not? Just think about some of the applications. So we have metro system. So just think about this metro, okay. So like in Hyderabad we have this metro, in Kochi we have metro, so in Mumbai, Delhi, so many cities at present we have this metro system which will run with electrical energy. We need continuous electrical energy. These are our priority loads for entire India. Some of the things are very priority, okay, like this load is priority. See, we are calling this one as the load because it's taking our electrical energy generation. So whatever it is, from where it is generating, nobody knows, okay. So it will be coming to the grid, and that energy we are sending to the transmission lines, and from there to the loads. Understanding? So think about this, okay. So like 1 or 2 minutes or 10 minutes without any electricity, if it happens like this, then it's a huge loss for the entire system, and it may be more dangerous for the lives of people traveling in that metro. Understanding? So that's why what we need certain kind of power plant which will run immediately and which will give the energy, electrical energy output as early as possible. That's why we need this gas turbine power plant. Understanding? So we need this gas turbine power plant. Understanding? That's how we want this gas turbine power plant technology. So this is, we are not only using in our electrical system, for the airplanes we are using, okay. So you may not think, okay, like this, in the airplanes we have certain kind of engines there, okay. So 2 engines will be there on under the 2 wings. So there is also some air is coming, so there is also burning is happening, and so that engines are different. We are not using gas there. It's gas means it may not be gaseous, it may be liquid, it may be solid, and it may be combination of some of the fluids, or it might be petrol also. Understanding? So it might be petrol also, which will give the combustion. That kind of gaseous fuel we have to use, okay. Instead of fuel, why we are calling this one as a gas means it's a gas. Which kind of gas? It may be liquid type. So that means from the liquid we are generating. Understanding? So we can use any kind of fuel here, there is no problem to use, okay. So this kind of power plant we need. So there are so many advantages. This is only one advantage I'm just telling you. So this is a major advantage to use the gas power plant, okay. So and in Telangana or Andhra Pradesh, in South India, okay. So previously we have the gas turbine power plants. At present this technology, so we are not having completely, so we need to upgrade these technologies. Understanding? So previously in Andhra Pradesh, okay, so we have certain kind of gas turbine power plants. So now also there are some power plants like this. Still we need this upgradation. Okay, so that's what we can understand. Okay, so anyhow, this is the need of gas turbine power plant. Okay, so up next we will see about the basic operation of gas turbine power plant. See, I have told you this class majorly we are concentrating on so the advantages of gas turbine power plant over the steam power plant. So to understand this first, we need to know the basic operation of gas turbine power plant. See, these are the major components. Okay, so I don't want to give this schematic diagram like this. I will draw one by one. Okay, so I will draw one by one and explain for you. Okay, so you might have know after this what will happen, but it is simple. Okay, see, combustion will be happening here. What is this combustion means? Burning. We need to burn the fuel. So whenever you burn any fuel, there will be some exhaust coming, right? And we need to use that exhaust here. That means outcomes of this combustion we need to use and we need to send it into gas turbine. So because of that, the turbine will be rotating and rotational force will be converted using a shaft and coupling will be there. Alternator, okay, it will be three-phase alternator. Okay, so it will be generating and after that we will be connecting the three-phase transmission lines and to the grid it will be going. Okay, so that is the one. Okay, so basic operation. So but why we need this compressor? Why we need this compressor? We need to compress the air. Okay, so air, because air is required for the combustion process. To burn anything, definitely air is required or not. So previously in childhood days, okay, so whenever, so like it may be your childhood or your kids childhood, okay, so anything. Okay, so understand, for the smooth combustion process air is required. You might have understood. Okay, so we will blow the air into the fire, then automatically burning process will increase and more faster the combustion will be. Understanding, right? That means, so we need air. Okay, so we need air in the combustion. For the smooth combustion process, we need air. Understanding? So think about one thing. Directly air required, we understood. Not only air, right? If you compress that air and if you increase the pressure of that air, and air molecules are very narrow like this, that means they are concentrated. So you might have understood. Okay, so one pipe will be there. From the pipe only, so you will be blowing the air into the fire. So why we are doing that? What is advantage we are getting there? So all the whatever air it is coming, okay, so all the air it will be going in a narrow tube, means the air molecules will be very compressed and very closely packed, and all the air molecules will be going at the same time on the fire. So that means the combustion process definitely improves because of that. So that means we need to compress the air. Understanding? We need to compress the air. Okay, so how to compress? Using a compressor. Okay, so I will tell you more about these all components later. Okay, so this is the basic operation only. Okay, I'm not explaining about this one. This is only basic operation. We need to learn more about this one. Okay, so each and every part have certain details for us. Okay, so we need to learn. So air we have to take. Okay, from the atmosphere only we have to take this air. And in the atmosphere there will be so many components also will be present. Okay, so that's why we need certain filters. Okay, so dust should not go inside because the combustion process may not be proper. Okay, so that's why, so the filters we have to use. Okay, so that will be burned here, and the gases will be coming to this turbine. Because of that, the turbine rotates. With the turbine, the generator rotor will be rotating. So after that, generation will happen. Okay, so generally if you are electrical, okay, so you know about this part already. If you are from electronics, okay, so you will learn this one from the basic electrical engineering concepts. Okay, so how the machine, how the generator will be working. Okay, so that's what you will understand. Okay, so this is about the basic operation. Understanding? So but because of this operation, where we are finding some advantages, this is similar, right? This is similar. So instead of compressor and this combustion chamber, we have boiler. Yes or no? We have boiler. In a thermal power plant, we have boiler here. We have boiler. For the boiler, we are sending the coal, and we are taking the air. See, this is rough diagram only, okay? I am not giving complete one. So you might have understood already that one, okay? So air also we are sending, and water we are sending. See, to improve the process, okay? So this is the boiler. To improve the process, what we have did? So instead of sending raw coal, what we have did? Pulverized coal or powdered coal we are sending inside. Okay, no problem. Okay, powdered coal. Okay, so powdered coal we are sending inside. Okay, first thing. So why to send this air, normal air, atmosphere air? We need to heat that air. Okay, so we have used air preheater. Okay, so air preheater. Okay, so then this air will become hot air. That air we are sending, then smooth combustion is happening. No problem. Water also, why to send the directly from the pond? Understanding? Why to send from the pond? So we need to send the hot water, then it will be more good, right? Conversion of this hot water into steam is more smooth operation, right? That's why hot water we need to send. Okay, so that too, pressurized water, low pressure heater, high pressure heater we are using. After that, okay, so pressurized hot water it is. Pressurized hot water we are sending. Okay, because of this all, okay, so there will be some steam produced. Okay, so steam production will be there. Understanding? So that steam we are connecting, we are sending to the turbine. Which turbine it is? It is nothing but steam turbine. Okay, so steam turbine it is. So we have learned about these all concepts there. Okay, just the basic. Okay, and see here the process whatever is happening here. So similar process is only happening here also. Instead of steam turbine, we have the gas turbine. Instead of sending the steam as the input, we are sending gases, exhaust gases we are sending here, or burnt, whatever burnt here, that output we are sending here. Understanding? So that output we are sending, and similar process, it is also rotating, then alternator is there, this is all same only. So there will be definitely some feedback, okay, so like exhaust to atmosphere, okay, so may not release to atmosphere, we can use again this hot, whatever air is coming outside, okay, hot air, so that we can use again. Here also, whatever steam will come, okay, so exhaust steam, see, output of this one is exhaust steam. Exhaust steam or used steam, it will be again converted as the water, and again we will use that water, so we will add some more water to that, and we are using again. This is just like a feedback, okay, so forget about this feedback, everywhere it is there. Here also we can use, there also we can use, there is no problem. But see here, because of this one, okay, so what is advantage we are getting? One gas turbine I have told, and that is the thermal power plant operation. Okay, so what is the advantage we are getting? That's what we need to understand. So there are so many advantages we have, so you won't believe. Okay, so at each and every stage we are getting advantage using this gas turbine power plant. So in our next session we will learn about so many advantages of this gas turbine power plant. Then we will go to the complete operation of this gas turbine power plant. So then we will compare some of the other things also about this. Okay, all the best. Thank you so much.